All right. I guess I'll start. People will wind up filtering in the first couple of minutes here. Is anyway going to be kind of what I talked about yesterday at the start of my talk. Is basically for my church security team, we had a need to be able to alert each other in different parts of the building, and where we weren't necessarily couldn't necessarily see each other. So the idea was to make a kind of something that looks like about the size of a cell phone that allowed us to kind of hit a button, and then that would alert the rest of the people that are on the team, and then someone would be able to press their button and alert the person that originally sent the alert that, hey, help is coming. Um, we weren't able to find anything off the shelf that would do the trick. So yesterday's talk was on the electronics part of it. So today I'll cover the 3D modeling and 3D printing of the case. So I'll start with the 3D modeling part. I used Fusion 360 as the application that I was going to do the modeling with. Just to verify, folks can see that screen.
Looks good.
All right, excellent. So I used Fusion 360. I've done a couple projects in it, but what I found was the most helpful when I first started was to actually go through Autodesk's tutorials for Fusion 360. You learn a lot of the terminology, and you get kind of a rough, like 10,000 foot overview of what are the capabilities of 3D modeling. I mostly just use the relatively simple parts. They're for everything that you wind up doing, at least the way I use it, is I start with a sketch, which is a 2D drawing of your design. A completed project like this will actually have multiple sketches all throughout, potentially. And the sketch is basically giving you the 2D design that you're going to work on. After that, then you're going to do extrusions and a couple other commands based on where you're actually working in the 3D part of the project. So I'm going to show, or at least hopefully help define some of these parts. For Fusion 360, everything is stored in the cloud at this point. The app itself is local, but all of the models or designs that you've done are stored out in the cloud. You can save off parts of things, like you can save STL files, which I'll get to when we get to the 3D printing part here. But I'll start at just the, this is a sketch. So inside the sketch, we have a bunch of dimensions, shapes. So these would obviously be circles. This curve here is called a fillet. And this, the entire outside of this box basically has an offset, which we can see, that's the measurement there. So one of the things I found when I was doing this is in the 3D printing world, at least with your FDM printers, typically your nozzle sizes are based in millimeters as opposed to inches. As a woodworker, that's very disconcerting for me, but so I have actually started using millimeters for all my sketches. My older use of Fusion 360 is all doing in 1/64 or 3/64 of an inch to approximate, but I've decided now to do everything in millimeters just to allow my prints actually to be a little bit better. The area that really matters is this is an outer wall. the part you see highlighted there. And when I was doing 64ths of an inch, it would wind up doing 2, and then it would estimate, and it would just leak out the um, what do you call it? Um, the filament or the plastic, so it wouldn't be as strong of a wall. That really showed up. Come on, oh, it's gone into. All right, one of the things I found is that overall, Fusion 360 is very good, except for it has some issues where it winds up not being, or I should be able, there we go, drag things around. So this wall here in particular, which is, I believe 120, yeah, 120 or 1.2 millimeters thick. That wall is really weak if you are less than three full nozzle widths wide. So, so let me go on a little bit more about. So, to design a sketch as your first step. That's going to tell you where to do the extrusions. So, I'm going to clear that out. Now, extrusions on this particular project, I had 2 to start out with. An extrusion is basically you select what components you're going to actually extrude and then give it a distance. Here I've got a negative 1.2 millimeters. That's because the actual thickness of this that I want is 1.2 millimeters. If we look at the next extrusion, the next extrusion is 7.25 millimeters. Normally, I try to keep everything. There's a layer height in 3D printing also, and I try to keep it a multiple of that when possible, just because you can get that under extrusion, which winds up making kind of flaky parts. So this is the actual height of the inside of the container that I want. One of the cool things about Fusion 360 is there's a timeline involved. So we can actually back our timeline up so you can see that is the initial shape. Then if we move forward, I'm going to add a fillet. A fillet is basically curve and edge. So if we look at this, we can see that I'm using a 4 millimeter fillet. That means the curve is 4 millimeters in height from the bottom. So that gives us that rounded, smooth edge. And if you're familiar with any cell phone, you've seen that a little bit of a smooth roundness there. That prevents those sharp corners that you wind up with. The next step that I did, and this isn't necessarily the right way, when you're working with it, you'll find different ways to pull things off. But I did a shell command, which made it so that fillet that I put on there, I get a constant thickness of the wall. Then if I actually turn on my sketch, or make my sketch visible, you can see that original sketch, all the components that are in there. So the next part, there's a thing called offset planes. So an offset plane, actually, let me just show you there. Normally you've got your origin plane, which is where you attach a sketch to. Once you have that, though, you can then do an offset plane, which you can see now is actually that blue plane that we're looking at is at the top rim of my model at this point. And that offset plane, you can do relative offsets. So it is tied to that rim. So to make this entire thing thicker, instead of that 7.25 millimeters, then this offset plane would travel with it rather than having to actually give it a distance off the origin. And that's a number of things that you can see here. We can select, you can do distance, and you can do two objects. So we could actually make the plane off of the rim itself. So I added another sketch here. We do another step forward, and you can see that sketch is, let's see, turn off the other one and actually look at that sketch. Down here. So I can even turn off the bodies or the models behind it. But here you can see, actually I'll turn that other bottom sketch on so you can just see. What I've done is you can, on sketches, you're also able to, as long as they're in the same dimension, so this I think is the Z dimension, you can take points from another sketch and project them into another sketch that's above it or in the same parallel plane. I guess that's the term I'm looking for. So I'm not going to go through the whole thing here. I'm going to actually go ahead and create a new model or a new design. So a design is the entire component at the end, or all the definition for a component at the end of the project. So let's see. So design, new design. So first thing that we do is we need a new sketch. There we go, create sketch. You're going to select which plane you're going to create the sketch on. I usually do the XY because just to me that makes it fairly logical. If you do the drop down here under create, you can see all the different prototypes that you're able to use. You can use lines, you can use rectangles, arcs. Some of them have a shortcut, like you can see the center diameter circle is one of the prototypes we can use. So if I do C for that, I can then create a circle fairly easily. If we hit D, which is again one of the additional tools, let's see, sketch dimension. So if we want to do a sketch dimension, there we go. You can drag that out, and let's say that is 10, or let's say, yeah, 10 millimeter. If we clear dimension, it'll keep doing dimensions. Let's make a rectangle. So here we go, 2-point rectangle. We'll start at the origin, and we'll, doesn't matter the size exactly. One of the other things that we're able to do is add constraints to two components here. So if we want this tangent to be on this circle and along this top, it'll automatically move it for us. And we can also make it head out to this corner here, for instance. So constraints are one of the other things that we can do. As soon as we wind up setting a constraint, if we wind up wanting to do a chain or over constrain is the term. So if we want to do a dimension from here to say there, that one, it'll give us a warning that adding this dimension will over constrain the sketch. And that it won't allow you to do it. But if we say OK, it gives us this dark green dimension. And that is really tough to read. But that will allow you to get a measurement, but not actually constrain it. So here, if we wanted to change this to, say, 40 millimeters, it'll update that dimension there, but it's not allowing us to change it on our own. So if I try to edit that, it just won't let me edit it. So that means there's another dimension that's actually defined. So we've got a sketch now. It's not a terribly interesting shape, but we can extrude. The shortcut for that is E, but if you look here, all of these things look three-dimensional. There's a couple shortcuts you can do, but I'm not gonna. E is the one we can either drag it by the arrow up and down, or we can actually give it a dimension here. So let's say 30 millimeters. So the reason that we did not get all of that sketch, or all of the shape from the sketch, you can see that we knocked out little parts. That circle that was in the corner. We can go back and actually edit the, here, we can see we've got one selected, one profile selected. We select another profile, we can bring that up. And we could just fill it out all the way by selecting all three profiles. So let's do one more extrusion, which is actually going to be a removal. So we're going to select just that circle along the bottom. And let's say for relative dimensioning, we start from the profile plane, but the distance that we're going to do will be to object. So if we select the to object as that far face, you can see that it defaults to cut down here. We can do one more thing on that offset. Let's do minus 8 millimeter. So instead of actually boring a hole all the way through, we're going to go from this surface to 8 millimeters from the top. So that allows us, if we're looking at the top, it's solid, but when we come down to the bottom, see that it doesn't go all the way up there. So that is a lot of the just basic modeling part that goes into this. Is you're going to wind up, especially if you're doing something like what I've done, it's going to be a lot of extrudes, a lot of fillets, sketches. One of the other things we can do is we can select another face to do a sketch. So we can do create sketch. We can just select here. This will be a new face for us. I didn't do an offset plane, but let's we'll do another circle. Doesn't matter exactly what we're doing here. Finish that sketch. Now we can do a extrude off of this profile. And we'll go to that far face. So, sketch. All right. So we'll get to the far face here. We'll do a cut. So there's now a couple other options here. You can also do intersect, a cut, a join, new body, new component. I'm just going to do cut again. Let's see. So we can see that it goes all the way through. And we even cut through that other hole that we had. So this is how pretty much all of the steps went when I wound up making that case. So, oh, I am way running out of time to get to the next part. So I guess, does anyone have any questions about Fusion 360 as far as modeling and such goes? So the next part is actually printing our models once we've made them. And there's, I think I'm just going to cover FDM printing right now because it's not watching the time. So let me launch Cura. So when you're 3D printing, there's you need to translate this object into commands for the 3D printer to understand. With FDM printing, I typically use Ultimaker Cura. For printing with a resin printer, I use Chai2 box. Resin printing is done quite a bit differently. It's not G code. It is basically just a stack of image files that tell the screen how to print the image. But in Cura, you can see we get a empty build plate here. This is for my particular printer. I've got a nozzle size and then a number of settings, which right now I have supports off. That's probably one of the most annoying things to work with is figuring out a good support structure, which means you're printing extra printing that is going to hold pieces in the air rather than, or so they're not standing just free in the air. So in Fusion 360, we're going to do a save as STL. STL is the format that is a 3D model. We're going to send it to a print utility. There's a couple different ones. There's Mesh Mixer, Print Studio, Freeform, Custom, which I'm not familiar with, but I typically send it to Cura. That is going to package up this model, and we now have it inside of our Cura. Inside of Cura, we can select that model, adjust which face is facing up. So we don't have to actually have supports here. We are going to do up that way because there's a hole there. Now, right here, we've got that other hole going through it. So this we would need supports. Otherwise, when it's printing the layers here, they would be unsupported and possibly droop or just overall just stop. There'd be extrusion, but it would wind up just dribbling down. So here we'd turn on support. Then we'll do a quick slice, and I will show you what does it look like. So here we see the bottom layer is printed or would print, go all the way up. Inside you can see a lattice work, and that is internal support so you don't waste a lot of filament. It's not terribly expensive, but it'd just be a really dense block. This way it's a little bit lighter and it hopefully is reasonably structurally sound. But as we go up, you can see we've started our hole right there. And we'll travel a little further up. You can actually see these blue lines that are going through those. Those are supports that are going to support these parts here where they're actually printing and nothing is technically underneath it. And then the print continues up to the top. So slicing is basically generating the G code, which is what the printer understands, so it's able to follow the instructions. There's a bunch of little stepper motors that the G code explains, like, hey, move the extruder to this location, extrude while you're going along this path, and how much do you extrude? And it does all the calculations of the volume of filament to the to figure out how much it should be extruding at any one point in time. I guess that's basically all I've got. I'm out of time, but I can answer any questions if folks have it. And it sounds like I've either disconnected or no one has questions. So either way, I guess
you're all good. Dave said there's nothing after you if you want to keep going, by the way.
Oh, is there nothing set up? Let's see. Oh, looks like you're supposed to be talking about Zork, Dave.
Supreme Leader Zork?
So, well, if no one has any questions, and there's a Zork talk coming up.
Refill filament during a print.
Oh, some printers are smart about that, and they will detect when filament runs out. Myself, my solution is, let me see, am I actually on video right now?
Yep.
My solution is to take the last little bit of filament and just not print that last if I don't think there's enough to finish the print. So I wind up with all these spools of, I don't know, maybe 1 or 2 meters of filament left over. But some of them will actually stop the print and allow you to switch filament in, and it'll then reheat everything up and take over where it was. But those printers are more expensive than I was willing to spend for originally.
And do you have to keep like a camera on the print to make sure that nothing, messes up, or how do you monitor for a long print?
I don't have a camera set up for it. I work from home most of the time, but well, actually, I guess at this point I work from home all the time. So, and the prints that I was doing for the cases, my tops take about 8 hours. The bottoms of the cases take about 12 hours. So with those, I wind up, I'll just start one before bed. Then in the morning, if it printed, great. If it didn't, bummer. I'll just set it up to go again. I don't get too many failed prints at this point, or if they fail, they're going to fail in the first 15 minutes of the print, typically, not adhering to the bed. And I guess I've got probably about 20 to 25 different case pieces that I've printed as I like, oh, that hole didn't align up right for the screws to hold that component down. So reprinting is something that I do a lot of. At this point, I'm working on a new case top since I've switched from using LED arrays to OLED screens. So I'm having to print some new tops to get those to line up nice.
Got it.
So, oh, I guess that's right. I guess I kind of, so this would be the top. The bottom has a number of mounting holes and screw holes and risers, just to give an idea of what it looks like on the inside. So, any other questions or? All right, well, I guess I will sign off here and hop on one of the other talks. But if you do have more questions, just go ahead and shoot them to me in not Slack, but Teams, I guess. So have a good one, guys.